Hello everyone, welcome to part 2 of this week's video tutorial. Now, for this part, we're going to talk about solving optimization problems through two examples. So let's first look at the general procedure. So the general procedure for solving optimization problems is that first we need to frame what the problem is, right? So we need to look at what variables in particular we can use to represent which entities are changing, right? So these are the changing parts, and then look for the relationship among these variables. So any constraints, what is the objective, etc. So for example, okay, so the final goal is really to formulate the problem as an optimization problem, such as that we are maximizing something or minimizing something, right? And then these particular points, which we call the optimum points, is often found by solving for the equivalent numbers of this function f of x, which we formulated from the step 1, right? So what do we mean? Let's look at one example. So here in this case, we have one example. The homeowner has this budget to spend on building a fence, which is illustrated here, right? And then it's a rectangular garden. So it means, of course, the first response would be what is area, right? So the area of the garden is actually just the length times the width, right? So if, for example, if we express the length and the width is x and y, right? Well, okay, then naturally it's gonna be x times y, right? So the question further says that the three sides of the fence will be constructed with referencing at a cost of $2 per linear foot, right? So what this means that this is the cost per unit. And for example, here we have marked the cost per unit. So three sides, right? So 1, 2, 3 is 2. And then the fourth side will be 6 per linear foot or per unit, right? So it's going to be 6. Now, so this has something to do with the cost. So this is xy represents the length. This numbers represents the cost per unit. So now, of course, we can say the what is the total cost, right? So the total cost. So cost is gonna be so we have three axes, right? So we have okay. So let me just get it right. So we have actually 2x, right? So this is the one side plus 2x. So this is 2x, and this is y, so 2y, right? So this is not 2x. This is 2y and another 2y. So this 2y and then 2y, and then one more is 6x. So 6x, right? So basically what I'm trying to do is that so we actually want to calculate the total cost, right? The total cost required by this rectangular garden. And we can add things up to give us 8x plus 4y. So this is our cost. This is our area, right? And then the question asks, what is the dimension? So what are the dimensions and the area of the largest garden that can be enclosed with this budget? So which means that we need to equate this budget to 0, right? So to 0. And then, so under this constraint, so this is our constraint, right? So whatever we build, they have to conform to this budget. And we want to say, okay, with budgets, what is the maximum area we can get? So we want to maximize this area, right? Which is x multiply y, right? And then and also solve for x and y. What is the optimum dimension, such as my area is maximum, is maximized, but also I used the budgets, use all the budgets, right? So this is a step where we introduce variables, and of course now we have this, right? Which gives us y as a function of x, right? So we can express y as a function of x, which we can say this is actually 80 minus 2x, right? So we can express y as a function of x. Now this becomes x multiply 80 minus 2x, then so this is one function. So basically we are solving for the function, right, which we call area. or A, right? So use one letter to express it. So we want to maximize this function, and then such that the cost constraint is satisfied. So this is constraint we plug in, but there's one caveat, which is that the length or the width needs to be above 0, right? So this gives you one domain. So so x needs to be within a certain domain, right? And then this domain give you two starting point and endpoints. So these are two endpoints. And then when solving for the maximum points, we can use the usual trick, which is to check the first derivative, right? So we can get the first derivative and then set to 0, which gives us a critical point. So which is to give us x to something as a critical point. So critical points. Now this critical point is only a candidate, right? We're still to do the comparison with these two candidates here as the endpoints, right? So now with one, so this is our one candidates, two candidates, three candidates. With these three candidates, then we can say, oh, what is the actually the points, the value of x actually makes the area A is maximum, right? So this is how we can solve for this problem. Again, through this process, I hope you appreciate that's how we gradually move from the text information to variables and then gradually write down the subject of interest. So in this case, it's the area and the cost. All right. So that's one example we can look at. Now let's look at one more example, which is maximizing the revenue. Okay. So what this is about is that my trading company price is similar. Basically, the price is 400 per person, and there will be 100 persons attending the seminar. So so 400. So basically, we know that it's gonna be the price, right? So this is the price, and then this is the let me just draw a table here. This is the people, so the number of people. Okay, so it's gonna be 1,000. Now it also says that the company estimates that for each $5 reduction in price, right, and then an additional 20 people will attend. So what does this mean, right? So for each $5 reduction, so if I reduce by $5, which gives me 395, right, then my attendance will increase by 20 people. So it's going to be 1,000 plus 20, right? So this is each $5 reduction. So what about I reduce by 10 people, that's $10. So 400 minus 5 multiplied 2, right? I have another 20 people, right? So it's going to be 20 times 2. So we can do this on. Now, what if we're, so this gives a hint, right? So we can actually change the number of reductions, right, in price in terms of $5. So this, for example, this is multiplied by 1, multiplied by 1, multiplied by 2. What if we multiply by n, right? So if we change x $5, right, it reduce $5x, reduce x prices in terms of the $5 reduction, right? Do it 5 times. Now this is our price and this is our people, right? 20x. So that's sort of the interpretation from the text. Now the question asks this: so how much the company charge, right? So charge means what should the price be, right? What is the price should be in order to maximize its revenue. So we have this notion of revenue. Now, what is revenue? So revenue, R, is something that we can calculate, right? So we have the price, and so we have the number of people attended. So it's going to be 400 just multiply 1,000 in the first case. In the second case, basically is this one multiply this one, right? So this one multiply together. So dot dot dot. Now, if we express it as a variable, right, and then we have this function. So this is our price. This is our number of people attending the conference. So now this is the form of our revenue, right? So revenue equals to this form. Now I want to maximize. So maximize this function. then we know what to do, right? So we just take the first derivative set to 0, set this to 0, and then solve for the critical number, right? So we have a candidate, but we also need to pay attention to the range, because the price cannot be negative, right? So we have it can only be 0 or positive, right? So now this gives us a range. So within the range, then we know what are the values of the endpoints, and also what are the values when x takes the value of a critical number. Now we compare which revenue is the biggest, then that is our optimum price. So then we optimum the x value, right? Now we can plug in this one to get the price. So that's how we can solve for the optimum revenue. So, okay, so in this example, I also hope that you can appreciate how we move from the text to gradually analysis on what kind of variables we can choose to solve for this problem. All right, so that's it for these two examples, and thanks for watching, and I'll see you in the next video.